Should we be seeing more people here?
Okay, I think that's the wrong screen. Okay, it keeps sharing the same screen here. That's not the one I wanted it to share, but and I can't start it from there. Okay, not sure which screen you guys can currently see.
I see what you're sharing, Randy.
Yeah.
And
which one am I sharing currently?
right now you're sharing the slide deck, Cybersecurity Test and Evaluation Top 10.
All right, that's what I thought. I'm trying to share the running scenario, which should be that one.
We still see the Thursday script one.
Yeah, that's what I'm seeing is not the script one. I'm seeing the presentation. All right, well, let me click through that. Huh, sharing screen is closed. Well, let me try again. Slight technical difficulties for anyone that's listening in. We will be officially starting in a couple minutes. Okay, you can probably see the slide deck now.
Yes.
Okay.
Yeah.
Start from first slide. Can you see the first slide?
Yes.
Of your slide deck, we see the first slide.
Okay, good. Okay, we'll wait just another minute or so for people to connect in. For those of you who have connected in, we are case studies number 1 for session. Well, I've got about 2 minutes past the hour, so I'm going to assume that people that are interested in this talk, which of course should be everyone who's attending the conference, have already successfully connected in, and we will begin. Welcome. My name is Randall Smith. I'm retired recently from the Boeing company. I have with me Sarab Sintry from Norton LifeLock. He is my co-chair, and we have Pete Christensen, who will be giving today's talk. So Pete will be talking about cybersecurity test and evaluations, lessons learned, top 10 lessons learned. I encourage you to go look at the bios. I think that Pete has a very interesting bio. He was a U.S. Navy commander with over 2,000 hours and 550 carrier landings in EA-6B prowlers. I can't even imagine what it must be like to bring one of those jets down on that little thing floating around out in the ocean. But I met Pete a few years ago when he was working for MITRE, the MITRE Corporation, and he was serving as the director for the National Cyber Range under the Test Resources Management Center, TRMC. And so today, with today's talk, I hope you'll enjoy it. I think that it does have a lot to do with impactful and deployable cybersecurity, especially for you researchers out there. If you're developing new techniques, think about how those need to be tested before they can be employed successfully. And with that, I'll begin the presentation.
I'm not hearing audio, Randy.
Okay, can you hear the audio now?
Cybersecurity and cyber
Yes.
resiliency test and evaluation.
and help you to do that for your programs. It's important because testing gives us actionable information that decision makers can use to make decisions about how to move programs forward. I'm going to give you some background regarding cybersecurity testing, how we do it here from a DoD and DHS perspective, and then share some best practices with you. In terms of defining cyberspace, there's the textbook's definition, which is listed here. But cyberspace perspective is portioned into three layers: a physical network layer, which has your compute and store infrastructure; a logical network layer, think of that as the internet and the different kinds of technologies that connect those physical layers; with a cyber persona layer, where we do cyber or different kinds of operations. These three layers are graphically depicted here from a joint pub. You see this physical layer has these compute and store assets that are positioned throughout the earth, in space, undersea, wherever. They're knitted together using this logical network layer, and they're operated at the cyber persona layer. It's really hard to protect because it's cyberspace. The cyberspace, this thing that we've created, is man-made and mutable. The physical layer has a number of highly diverse, widely distributed mission-critical assets. This logical layer abstracts the physical layer from the cyber persona layer. And up at the cyber persona level, we don't understand how our missions are dependent upon the underlying logical and physical infrastructure. So we have some real difficult challenges in terms of trying to determine how to protect them. How do cyber threats exploit vulnerabilities in cyberspace? Well, if you use the Stuxnet worm as an example, at the physical layer, the target were the heavy water reactor programmable logic controllers. The Stuxnet worm exploited the logical layer of the network to get into those PLCs. And at the cyber persona layer, not only was there removable media that may have been used to introduce Stuxnet, but was also released throughout the internet, and it had some pretty devastating or effective results, depending upon what your perspective is on those water reactors. So, if I think back to when I was a kid and some of us were kids, or early on, cybersecurity testing was easy. If you look at this 1948 coupe at the Porsche Museum, there's 0 source lines of control, or source lines of code, and 0 microcontrollers. But modern automobiles today have hundreds of millions of source lines of code, 70 plus microcontrollers. And it creates a significant challenge in terms of trying to test and evaluate it. If you think of how these hardware and software components are interconnected logically using these different kinds of bus architectures to create automobiles, airplanes, whatever, and then they're interconnected with things like cellular architectures and air traffic control networks, it creates an attack surface which is extremely massive. So the cybersecurity lessons learned, in my mind, come from my last 20 years of executing testing, as well as cybersecurity training events for a full spectrum of DoD and DHS programs. And what we've noted historically is that cybersecurity testing creates some significant technical debt. From a software programming perspective, this technical debt reflects the additional development work that we need to do when code is easy to implement in the short run, but it creates problems for us in the long term. And there are two kinds of technical debt. One kind of technical debt is occurred unintentionally through some flawed design or implementation. But the other kind of technical debt, and we see this many times in government programs, is the decision to optimize for the present so that we can move a program through more rapidly through the acquisition process. And often we do that by just eliminating test and evaluation. Well, that's not the right way to do things. And from a Department of Defense perspective, if we think about what are the primary sources of technical debt, we see the first source are cybersecurity requirements that are constrained. We don't think about the complete attack surface, or we're focused on just controls verification, which is necessary but not sufficient. And then the other thing we've done is we've either constrained testing by venue, in other words, we haven't had things like cyber ranges to do testing, or we defer that testing until the system is matured just before we're ready to deploy it, and then we discover that we've got some significant challenges, cybersecurity challenges with the program. So the first lesson learned, and most important lesson learned, is that you need to engage the test and evaluation community early on and throughout the acquisition lifecycle to optimize those acquisition outcomes. The earlier you can engage testers, for example, in a requirements development process, and also early on as we're considering how to provision test infrastructure, we can drive down that type 1 technical debt. And if we think about testing by one, using by all, if we can test collectively, iteratively, and incrementally throughout the acquisition lifecycle, we can dramatically drive down that technical debt. So involve us testers as early as you can in the acquisition process. I mentioned as lesson 2 here that cybersecurity testing is iterative and incremental throughout that acquisition lifecycle. It isn't one big bang test at the end of the acquisition. It's incremental testing early on at the software subsystems and components, testing the networks, and then testing the systems from an operational perspective. And it's not just functional testing, testing functional requirements, it's also testing cybersecurity, which is often referred to as non-functional requirements. And again, we complement by getting involved early on. These initial iterations of testing can reduce that type 1 technical debt, fix the problems early on with bad requirements, and later on, later on testing can really help us to understand the mission risk, because there are always going to be some kind of residual cybersecurity vulnerabilities associated with the program. How significant are those residual risks from a program mission perspective? Effective test teams understand the adversary. It's very important now for us to understand who the adversary is and think like them and think about how they would attack our systems. So cyber attack life cycle is a MITRE phrase that talks about a framework or MITRE concept that talks about trying to understand and anticipate the moves of cyber adversaries in each stage of an attack. MITRE's also been advocating for something called ATTACK, which is again an adversary model or framework for describing the actions that adversary may take. And that what we want to do is use that understanding of the adversary to shape our test program to try and identify and close exposures and vulnerabilities as early as we can in the acquisition process. Now, cyber tabletop test exercises are something that we developed when I was running the National Cyber Range to try and help program managers and testers understand the scope and scale of cybersecurity testing. I had many folks come to me and say, we know you've got a cyber range, we've got to do some cyber testing, but we don't know what to do. And we use this cyber tabletop as a low-cost, intellectually intensive war game that to try and understand the effect of the adversaries on our operations. It's used to identify potential threats, categorize them in terms of mission criticality, and then inform mission mitigations, engineering, testing, and design activities. It helps us, the output of the product or the process are these risk matrices that help us based upon the different kinds of adversaries we expect to encounter, what the likelihood is that an adversary is going to be able to try and exploit a vulnerability, and what the mission impact is. And this has been adopted as a best practice across D and DHS. I can't emphasize that iterative testing informs survivability and resiliency in a mission context, as well as driving down mission technical debt. And from a federal government perspective, often we focus on this thing called the risk management framework, which is designed to identify the baseline, the minimum controls, technical, operational, administrative controls that we need to apply on some particular acquisition program to try and minimize cybersecurity risk. The problem is that we often do that RMF testing independent of the cybersecurity testing, RMF may be necessary but not sufficient to be able to deal with the adversary. So if we act like the adversary, and on the left-hand side here, portray functional threats and use typical tools that the adversary uses to portray an attack, we can try and exploit weaknesses and discover if we, for example, if the controls as we've implemented them are effective, or if those controls are misconfigured, or if those controls are lacking, and then understand how that affects a particular system function and what the impact is on the mission. This is absolutely critical for us to understand the cyber survivability and resiliency of a system or system of systems. So we really need to think about doing this testing, not just in terms of controls verification testing, but also in a mission context. Start small and grow. This is an important lesson we found with large DoD operational platforms. An aircraft carrier is an example here on the right. In this notional example, an aircraft carrier has a number of different systems and networks that are used not only to control critical infrastructure, but also control warfighting networks, weapon systems, and aviation systems. And what we can use this early on developmental testing for is to try and determine if an adversary can create an effect on individual systems, try and understand how the adversary may use one system to pivot to another. We can use test venues like labs, system integration facilities, and cyber ranges to do this kind of testing. And then from an operational test perspective, once we put, for example, in this example, several instances of that arresting gear on board an aircraft carrier, we can attempt to access the pivot points and then determine if the adversary could get access to that pivot point, if they could then create effects on the platform. But we don't have to take the platform to failure. We don't have to take the arresting gear to failure. We've done that early on developmental testing to try and understand what the impact of those kinds of attacks would be. So start small and grow. The other thing that I think is particularly important here, lesson 7, is you've got to execute cybersecurity testing with all the right folks engaged. It's not just the software developers and the systems engineers. I need to think about the IT staff, the folks who are going to be functioning as cyber protection teams, for example, or cybersecurity service providers. They need to be involved in the testing. We can't just develop systems, throw it over the fence to an operator, have them incorporate into their network, and have them be able to protect, mitigate, and recover those systems. So we use red teams to portray the adversary against these systems, and we use the operators to try and exercise the system under test in a mission context to try and understand what the impact is of those attacks and whether or not we can defend against them. The other thing that I think was really important here is that in my experience running a cyber range, our customers required cybersecurity testing evaluation as a service and high fidelity test infrastructure. Just because I said I had a cyber range, that they didn't necessarily understand what a cyber range could provide, what kind of services I could provide, what fidelity needed to be deployed inside that cyber range, how we would verify and validate and accredit the range so that we could demonstrate that this was representative of a real system or system of systems. So what our customers needed was a full spectrum of services. We needed to hand-hold them through the process in order for them to be successful using the range. And if we're thinking in terms of crawl, walk, run, if we think about incrementally test, develop, test, fix, develop, test, fix, I can, over a period of time, incrementally provision that range with increasing levels of fidelity, which makes it much more useful to the customer as we prepare to deploy it operationally. The other thing that I think is really important is just because you built this range doesn't mean it's something you're going to throw away. If you invest in this multi-purpose T&E infrastructure, it can help programs to keep pace with the adversary, speed development, promote innovation. What we're talking about here is when I invest in things like SecDevOps environments, which are designed to improve the efficiency and delivery velocity of software. If we keep those environments operating and continue to mature those environments as the system moves through the acquisition process and after it's fielded, then we can get some tremendous use and reuse out of those test environments. And what's really exciting now is we're seeing industry beginning to provision digital twins, digital replicas of these physical assets, processes, and systems. And that not only does that allow you to test the system after it has become operational, but it also allows you to enhance the system over a period of time, plug and play with different kinds of components, and really get a long-term return on that investment in infrastructure. The last lesson learned I have for you is that the connectivity makes range infrastructure and location irrelevant. I ran a cyber range in Orlando, Florida, but my customers were positioned all over the United States. Within the Department of Defense, both the Joint Staff and the Test Resource Management Center have provisioned networks to support cybersecurity testing as well as training. DoD's demonstrated the ability to support distributed testing and training for thousands of customers, thousands of users. Taking advantage of these kinds of networks means that I can have a customer in Bedford, Massachusetts, or in Aberdeen Proving Ground, Maryland, and I can connect them into my range, and we can do this distributed testing. And so it really doesn't matter where my range is. What matters is can you touch my range from where you are? So in closing here, how can we advance the state of the art of cybersecurity and resiliency? Well, if you're an acquisition program manager or systems engineer, engage the T&E community early. We need to think about cyberspace as an operational domain. We need to think like the adversary and how the adversary exploits our systems. We need to expect the adversary is going to constantly find new and exploitable vulnerabilities. So we need to design these systems for resiliency and be able to continuously test, fix, test over a period of time. This concept of SecDevOps. Use these things like digital twins and software factories. Test early and often, and make sure that you evaluate cyberspace operations and cyberspace survivability, which means include those key cybersecurity operations personnel as part of your test team, so that we know when we deploy this system operationally, we're going to be able to protect, mitigate, and recover. Thanks very much for letting me talk here. I know this is a little bit of an unusual format for me and you. This is my email address and my mobile phone. Be glad to hear from any of you in the future and look forward to questions. Thanks. Bye.
Okay, thank you. Pete, please go ahead and unmute and go ahead and start your video if you'd like to share. And we'll take any questions. Surab, I'm assuming you've been monitoring the chat. So all of you who have been watching, if you have questions, please put them in your chat window. So Saurabh, you're currently on mute.
Yeah, I mean, the only question I have so far on the chat is from me. And my first question is that you mentioned that it's important to involve testing from the get-go in the development process. But does that involvement in some sense also impact the development process? Not just a question of like informing the testers, but do the testers also actively in one way or another influence the process of development? For example, you can say, hey, here's what we can test and here's what we cannot test. So development needs to happen within these parameters and this framework.
I think the testers have to be engaged early on, and they can positively influence the acquisition program throughout that acquisition lifecycle. I think Randy has heard me talk before or give tutorials, and often I'll be teaching or talking to T&E professionals, and I'll ask them, how many of you are testers? And they'll raise their hand. And I ask, how many of you are systems engineers? And some of them raise their hands, some of them don't. And the fact of the matter is that the systems engineering and test evaluation community has to be intimately married and engaged as early on as they can in the acquisition process to try and drive that down, that technical debt, and eliminate that type 1 technical debt that we're talking about. Does that answer your question, Saurabh?
Yeah, to some degree. We have a question from David Bellinson on the chat. He says, congrats on the 550 safe carrier landings. And he's curious to learn more about NCR and its current operational status.
Yeah. So I've been out of operating or running the NCR since probably mid 2017. But what's happened is I think some really good things. First of all, is the Test Resource Management Center had a couple of different what I would describe as range capabilities. Some things called regional service delivery points, which were positioned in places like Huntsville, Alabama, and in Pax River, Maryland. And they combined them to create a national cyber range complex. So that national cyber range complex now consists of a combination of the national cyber range that was in Orlando, Florida, and these other cyber range components. As I understand the current state of play, the Test Resource Management Center continues to mature those capabilities. They are building an avionics cyber range as part of that NCRC complex that will be provisioned, I think, in Eglin, Florida. So the range is being expanded and enhanced over a period of time. The NCR component in Orlando, I think, is going to be moved out of it was housed in a Lockheed Martin facility. I think that's going to be moved into a government facility. So we're seeing that NCR complex being matured, and hopefully that will continue in with the next administration. We'll see what's going to happen. Does that answer your question, David?
Okay, since David can't unmute, we'll assume that it does, unless he types something else in the chat window.
He
I
does.
think you typed in yes, thank you. So that's good.
Okay.
Yeah, I guess you're following the next question yourself, but I'll repeat it for our audience. It's from Terry Benzel. And again, he thanks you for the nice talk. He says, can you say anything about T&E early in the life cycle, that is T&E on conceptual models and research prototypes?
Yeah, so I think that's a tremendous question. And as I have moved out of this role of advocating for a particular range and seeing what companies like GE are doing with digital twins, it seems to me that the government should be asking prime contractors like Boeing like Lockheed Martin and these other companies to be in the early phase of acquisition and design and development. We should be asking them to provision these digital twins, and the government needs to be buying rights for these things so that we can mature them through the development process and have these robust and verified test environments available after up to and after the system has been deployed, so that we can continually develop, mature it, and sustain and grow those systems throughout the acquisition lifecycle. I think the earlier we invest in this infrastructure, the better it's going to be for the acquisition program in terms of driving down technical debt, and the better it's going to be in the long term in terms of being able to mature and grow that system in the long term. Does that answer the question, Terry?
So for a little background on that, Terry has been highly involved, well, intimately involved in the deter work. So she knows of what you speak.
Good. I'm glad we're on the same wavelength. That's good.
So I have a question for you, Pete. This conference attracts a lot of cybersecurity researchers, and I know that with your time at the National Cyber Range and working with Test Resources Management Center, TRMC, TRMC would come out periodically with their list of new research topics, new research things that they needed, much like a DARPA broad agency announcement. Can you speak to where you think the research community could best help in the types of things you test, as in, well, I'm thinking in terms of things like embedded avionics systems, which are not necessarily testable with your standard COTS tools, because they're not TCP/IP based necessarily. They're not necessarily Windows, Linux. So where do you see the gaps in that area that researchers could help?
Yeah, so I would argue that one of the shortcomings of the NCR is that it wasn't necessarily configured at the outset to be able to evaluate things, operational technology as an example, or avionics systems as an example. So, and I think the services saw that. So that's in part why the Air Force advocated for the development of this avionics range, which TRMC is in the process of working with the Air Force to provision. But if you look at the pedigree of the NCR was developed initially by DARPA, and they envisioned this NCR as being an environment where they could do some kind of leading edge researchy kinds of testing and development of testing. When it was transitioned to the Test Resource Management Center, the testing community saw the immediate value of using the NCR to be able to support customers in their pursuit of cybersecurity testing. So the primary customers for the NCR were more operational kinds of customers, and then of course training was another thing that we had an ability to be able to support. From something that continues in my mind to be underrepresented from a test infrastructure perspective is our operational technology kind of capability. So that would be, and maybe the power grid isn't the perfect example, but it's one example industrial control systems, water systems, smart cities, those kinds of things. We really need test infrastructure that's going to allow us to wring out not just the functional capabilities of those technologies, but also identify and close the holes, the cybersecurity holes that invariably are built into these systems. So we certainly have to go that way. When I was at the NCR, we built some specific avionics test environments, some specific industrial control systems test environments, and that's certainly, I think, a way we've got to go. So hopefully that scratches the itch, Randy.
Yeah, I could see a future top 10 hit list of, these are the top 10 hard research things that need to be done in order to enhance cybersecurity test and evaluation. Thanks, Pete.
There's one question from Karen Davis. She asks, how do you change the culture to get system and design engineers to listen to the test people? All too often, test engineers are seen as lesser or not as smart. And when from what I've seen in practice, the test engineers are often smarter than the design guys. They have to be. I'll just add another point to this. This is actually something that hits close to home. My partner also does a lot of testing for, she works for a security company. And that's every single day, that's the complaint that I hear, that development engineers don't seem to care what the testers have to say, and they don't want to respect the process because, I don't know, it's hard to understand what the reasons are.
Yeah, so I would argue if the systems engineers were so smart, they'd build systems that by definition worked 100% of the time and had no cybersecurity vulnerabilities, right? I think the way the DoD has done it is they have, for the big ticket acquisition programs, those programs have the director of operational test and evaluation oversight on those programs, which almost forces the active and early engagement of the operational test and evaluation community in those acquisition programs from day one. So that is a method that works, but it's not optimum. I think what you've heard of extreme program. I'm sure this is from a software development community perspective. You've heard of things like extreme programming and moving towards software factories and SecDevOps, and building these kinds of environments. And I think if we can begin to embrace the development of these kinds of production environments to build software, we can start to overcome that. I would describe as a condescending view of testers. And I don't know how many of you saw the SpaceX explosion yesterday. I thought it was just fantastic, because not only was it just if you watch the whole thing, what they found in that test shot, what they learned, what they demonstrated in terms of the capability was absolutely fantastic. And that thing was instrumented. The crash didn't faze Elon Musk a bit, because he said, we got all of the data that we need. And you saw that it landed hard, right? It had some kind of a problem in the landing of that particular rocket. They're going to figure that out, and that's not going to happen in an operational environment. you know, thank God that Elon Musk understands the value of testing. So that's my soapbox, I guess.
So I'd like to add on to that, Pete, to address Karen's comment. When I was gainfully employed not that long ago, we had significant challenges from a test and evaluation environment to try and bring that into the programs, the developers. They didn't seem to think that test and evaluation, cybersecurity test and evaluation was all that critical to what they were doing. They were trying to build features, functions, meet the requirements, little jab at Daniel Fagan there, to meet the RMF stuff, which, as Pete said, is necessary. It's not sufficient. It proves that it does what it is supposed to do. It doesn't necessarily show that it can't do what it shouldn't do. So we would use things like cyber tabletop exercises to bring red team type people in, evil type people, to bring system operators in, which developers frequently are clueless about. And we would go through various scenarios, and it was always quite entertaining to watch the reaction of developers when they would find out that, well, if this thing happened, this bad thing, the pilot would say, yeah, not a problem. I just turn it off, keep flying my mission. Or some presumably insignificant thing would happen and the pilot would say, oh yeah, that'd be a really bad day, mission abort, return to base. Through that sort of engagement early on in the development, the developers can understand what sorts of bad things people might try and do to their systems and better understand how they're operated. They do gain a little more appreciation for the test community when they experience that.
Randy, that is perfect. I absolutely agree with you 100%. Once you, and that cyber tabletop is a great example. Once you bring all those folks together and you start to engage like that, although what we found when I was running the National Cyber Ranges, initially we were the ones who were hosting hosting a cyber tabletop as an example. But as the systems engineering folks started to engage, they would start to take over what we were doing, and it became, instead of it was an us versus them, it was an us working together as a team, and we really got some tremendously positive results out of it. So.
As there are no more questions in the chat, I had one question from my side, which was that, and this might be something that might already be happening, but is there a move in the world of testing to go from saying that X component is good or bad, or it has certain, a warranty or whatever, to risk assessment, saying that, look, here is the risk associated with this, here's the probability of failure, or here's the cost associated with the likely failure. So is there a change in thought process of like trying to say yes or no about a certain component, then trying to actually understand its like, or say something about its risk characteristics?
I'm not sure I can answer that. I'm not sure that I can answer that question, but maybe one of the ways I might have seen something like that happen was when we were preparing for cyber tabletop on a particular program, and we went to students at the Naval Postgraduate School and had them do an open source survey to try and use only unclassified sources to try and find out as much technical detail as they could about a particular program. And it was amazing the amount of information that was publicly exposed about systems that were going into DoD platforms, and that changed how those programs would change the security classification guide for those particular programs and the kind of information that was being shared. Does that kind of sound like something that was along the lines of what you were looking for, Sarab?
Well, let me maybe try to rephrase the question differently. What I was maybe trying to hint at is that rather than from a testing point of view, approving or disapproving of a certain component of a system, you basically, rather than like a 0-1 classification, you say, okay, here is 0.5, or here's like, this is not likely to fail, or this component is likely to be risky, rather than trying to like tell other people to completely avoid this, and then allowing them to understand how it works in their own risk environment, rather than like saying that this component is bad and should not be used.
So you're talking about giving the system owners enough information about the vulnerabilities in their system and
Right.
how it might impact their mission so that they can determine how best to use it or about how best to mitigate the issues.
Right. Yeah, to some degree, but rather than like giving it the whole detail of what could be wrong, just like giving something which is a bit more understandable. So that's what I was getting to. But you're right. I think, Randy, the way you probably said it is better, that giving people enough information so that they can make their own better judgment while using a certain system or not.
Yeah, I guess I wish people would do that more. What we see more often is developers who are focused on demonstrating the functional requirements for a particular program, and they're happy because it works. They got it to work, and they haven't really thought about what happens if something doesn't work or something works the way it's not supposed to.
So again, it does what it's supposed to do. You don't know that it could also do things it shouldn't do. It's very hard for the system developers to do that second piece because they're so focused on how the system works, the functionality that it provides. It's hard to think out of the box and figure out ways that it could break or it could be abused. And that's where you need the test team.
I would absolutely agree. And this could be part of the reason why there is there's often a disconnect between the systems engineering and the test community, because from a testing perspective, you're often giving the developer information that he doesn't necessarily want to hear, and they may have to go back and fix something as a result. So you don't want to be somebody who's saying that the sky is falling, but maybe sometimes you're perceived as a roadblock rather than as a teammate or someone who's working together with you to forward the program.
Yeah, as a test team, you need to be able to provide your findings back to the system owner without telling them what they need to fix. That's for them to figure out based on how critical those things are to the way they use the system.
Yeah, absolutely.
Well,
Yeah.
Any more questions? Because we're coming up to the end of.
Yeah, I don't think there are any more questions on the chat.
Okay, well, I want to thank everybody for tuning in. Don't miss tomorrow's case studies 2. Saurabh will be leading that with 3 more presentations. Thank you very much and hope you enjoy the rest of your conference. Peter, thank you very, very much for your presentation
today. Thank you very much, Randy, for allowing me to present. I look forward to trying to participate next year too.
Very good. Thank you.
Thanks a lot.